Hello, seventh graders, and welcome to lesson 6. This is the last section in chapter 4, and today we'll be discussing scale drawings and scale models. Right? Let's start off with a little bit of vocabulary. We got 4 words today, but they're all very related. Okay, a scale drawing, first off, is make sure I got my pen here. A proportional two-dimensional. So I'm going to put 2D, stands for two-dimensional, drawing of an object. And one that I like to think about, and I don't know if I consider an object, but a proportional 2D drawing would be like a map. Okay, maps are proportional, and maybe you've never had to use it before because maybe you've always had Google Maps. But you can calculate actual distance on a map by using the scale of the map. Scale factor is the ratio of the dimensions of a scale
Please
drawing.
excuse the interruption. Mrs. Hayden just called and said the internet issue has been resolved. You will need to restart your laptop. Thank you.
Sorry for that interruption. To the dimensions of the actual object. So this would be like, if I said my scale factor was 1 to 5, that would mean whatever my actual object is 5 times greater than my scale drawing. A scale model then would be like, so similar to a scale drawing, except now it's 3D. So a proportional 3D model of an object. And a lot of times I think about science class with this one. You've probably seen like models of the solar system before. Okay, or maybe something like an atom, where it's too small. We need to make it bigger so we can see it. It can go both ways. We can make scale models of smaller or larger objects. And lastly, the scale is the ratio between two sets of measurements. Okay, and before we go on, I just want to show you a few examples of what I'm talking about when I'm talking about scale. So I just did a quick Google search here of some of the different things relating to scale, and a blueprint would be a great example. So blueprint of a house, you could see that it's scaled down. Obviously, when construction workers and engineers are looking at designing and building homes, they need a plan to follow, and that's their blueprint. And it's to scale. So obviously your house isn't going to be this small, but when you scale it up, it'll be the correct proportional size. You've maybe seen scale models before. This is of Gillette Stadium, so this is of a football field. And it's obviously a miniature recreation of it, but it's to scale. Okay. Again, scale of the U.S. Capitol building. It looks exactly like that, except just a lot bigger. And then lastly, here's kind of like the solar system model I was discussing earlier. So those are some different examples of scale that you might see. All right, let's try example 1 and see if we can actually put some of this to practice. Identify the scale factor for example 1. Okay, so what we're going to do is compare their scales. So we're given that an actual room's length is 144 inches by 108 inches. And in the blueprint, it's only 18 by 13.5. So first, we'll write a ratio using one of the dimensions. So we'll compare the blueprint length to the room length. So our blueprint is 18 inches in length, and our room length is 144 inches in length. Okay. And then I'm just going to look to see what my common factors are. Actually, 18 is. If I divide both by 18, I would get 1/8. 18 times 8 is 144. So my scale factor is 1/8. In other words, from this blueprint, I need to make it 8 times bigger to get how big the actual room is. Now, you could have done the same thing with the width if you wanted to. We just chose the length. So we could say, well, it's 13.5 to 108. And if you took 13.5 and you divided by 108, you would come up with that same number of 1/8. Okay, so either or doesn't really matter there. All right, go ahead and flip your page to the next example. It talks about a photograph that was enlarged and made into a poster. So the poster, let me grab my screen sketch back. The poster is 20.5 by 36. Let's change colors up here. So I'm going to imagine this is my poster, and it's 20.5 by 36. And it was enlarged. The photograph was enlarged to make this poster. So that means that my photograph must be smaller. I'm just going to put pick. Okay, so it must be smaller because it was enlarged to make this poster here. Right? It says the scale factor is 5:1. So this poster is actually 5 times bigger than this original picture. Find the size of the photograph. Okay, so we're going to think that the poster is 5 and the photo is 1, and then we're going to just simply write a proportion to find the length, and then we'll do the same to find the width. Okay, so the proportion we'll write is 36 over L equals 5:1. Okay, so the poster over the picture compared to the poster over the picture. Once again, cross multiply, and 5 times L is 5L, and 36 times 1 is 36. Again, find the cross products, and then just divide. 36 divided by 5 would be 7.2. Okay. We'll do the same then for the width. Instead of using 36 this time, I'll use 20, my other measurement. So 20 over the width equals 5/1. Again, we're going to write another proportion. Then we need to find the cross products. So 5 times W is 5W. 20.5 times 1 is 20.5. And then just divide. 20.5 divided by 5 would give you 4.1. So the photo is 7.2 inches long and 4.1 inches wide. And that makes sense. It should be smaller. This picture should be smaller because it was enlarged 5 times to get the poster. And actually, the easier method than maybe writing a proportion in this case, since we know it's 5:1, you could just take these and these dimensions, so 36, and divide it by 5, and you could take 20.5 and divide it by 5. And that would simply give you your answers because we know it's going to be 5 times smaller. All right, moving on to example 3 then, where we're talking about a map. So I referenced this a little bit earlier. It says on a road map with a scale of 1.5 inches equals 60 miles, the distance between Pittsburgh and Philadelphia is 7.5 inches. So that's on a map. What's the actual distance between the two cities? So in real life, all right, let me explain this a little bit more. That on a map, if you go 1.5 inches on the map, that's like saying you've gone 60 miles in real life. Okay, so it says when you measured on the map between Pittsburgh and Philly, it was 7.5 inches. So then what's the actual distance in real life between those two cities? All right, we're going to choose a variable, so let D be the actual distance between the cities. So I'm going to start off with my scale factor. My proportion is going to be 1.5 on the map is equal to 60 miles in real life. And I went 7.5 inches on the map. How far is that? So I'm going to call that D. So 1.5 times D equals, and then just multiply these, 60 times 7.5, again using the cross products property. All right, so 1.5D is equal to 60 times 7.5 will give you 450. Go ahead, flip over to the next page, and we'll finish here. So once you do that, to isolate D, so we had 1.5D equals 450. We just need to divide by 1.5 on both sides. Divide both sides by 1.5. And D will equal 450 divided by 1.5 gives me 300. So the distance between cities is 300 miles. All right. Lastly, please pause the video now, try the 3 check it out problems, and come back to see if you got them correct. All right, for number 1, if our blueprint length is 2 and our aircraft is 12, that simplifies down to 1/6 is our scale factor. So the aircraft model is 6 times bigger than its blueprint. And you'd get the same if you chose that for the wingspan. 3/18 would reduce to 1/6. Number 2, it says Mary's father made a dollhouse modeled after the blueprint of their home. The blueprint is 24 by 45, and the scale factor is 1.5 to 1. Find the size of the dollhouse. Okay. So, in other words, if my scale factor is 1.5, that means the dollhouse is 1.5 times bigger than the actual blueprint. Okay. You could set up your proportions for this one if you wanted to. For this, I'm just going to know that the understanding is for my scale factor is 1.5 times bigger. So if I took 24 and I multiplied that by 1.5, I would come up with 36 inches. So it'll be 36 inches by, I'm going to use the X here. And then 45 times 1.5 would give me 67.5 inches. Okay. And then lastly, for number 3, roadmap, 1 to 50. So 1 inch equals 50 kilometers. And sometimes, guys, it can be really helpful to include your labels so you can keep them straight. And the distance between Dallas and Houston on the map is 7 inches. What's the actual distance? So I'll just call it X. Well, cross multiply. So 1 times X is X equals, and 50 times 7, well, 5 times 7 is 35, and bring that 0 along. So 350 kilometers. All right, that does it for lesson 6 and scale drawings and scale models. Again, lots of uses for these in the real world. Please let me know if you have any questions, and that's all I have for today. I will see you next time.